I'm not sure where the room host is, but that's okay. No worries. Thanks all for coming today. Definitely do appreciate you being here. Thanks to the sponsors for helping making this happen, and thanks to the selection committee for letting me come talk to you. I definitely do appreciate it. I know it's late in the day. I know we just had some cookies. I know we've had lunch, so I'm not going to get anything too weedy. This is a relatively short presentation. My goal in this is just to give you guys something that you can take home, take with you, something that you can implement, probably on Monday if you really wanted to. But before we get into that all, I just wanted to make a quick introduction. My name's Adam Mikolajczyk. I'm not going to ask you to spell that, although if you email me, you'll need to know how to do that. Mikolajczyk sounds a lot easier than it looks. I'm a systems engineer at the Red Canary. We're sort of part of an engineering team that does network engineering for all different parts of the company, wherever they might need it. If there's a need, we fill it. I kind of fancy myself as a cloud architect engineer with a strong focus on security. Little thing about me, I'm just about 100 miles east of here. Those of you guys who know what Blue Knob is, I live on top of Blue Knob. Second highest peak in Pennsylvania by about 70 or 80 feet, so we kind of consider ourselves the highest. I don't think anybody lives at the actual highest one. So yeah, had an early morning driving over here this morning. I live there with my wife, my kid, and a very recently adopted shelter pup. That's him right now, named Manny. Great dog, but man, he's kept me busy. As I get older, I forget how much puppies can really just take a lot out of you. But he's been fun. Anyway, moving along. So we're going to talk about today, again, real short, real quick. What is Terraform Cloud? If you don't know that, you probably aren't here, or you probably didn't read the description. What are static credentials? What are dynamic credentials? Why do I want one over the other? Why is one better than the other? And how do I get there? Again, pretty short and sweet. I'll try to save a couple minutes at the end for questions. So let's just jump into it. Again, if you don't know what Terraform Cloud is, you probably aren't here. But just as a real quick rundown, Terraform Cloud is a software as a service platform. It's kind of a collaborative repository of all your infrastructure as code, your states, your resources, your policies, security, access controls, things like that. It's the axis of sort of rotation around which all your API-driven infrastructure as code gets deployed, gets turned from code into things out there in the world. It talks to any number of API-driven services. We make heavy use of it. We also make heavy use of AWS, among other providers, but AWS is kind of our big one, so this is where I'm going to focus on here. So again, that's what Terraform Cloud is, but again, I hope everybody here knows what that means. Statically defined credentials. So Terraform Cloud, what does that mean in terms of that? Well, AWS, we're familiar with, has IAM keys. You get your access key, you get your secret key. You've got Terraform, you plug those in either at the code level, bad idea, or at the environment variable level, better idea. You plug those into the workspace, and then every time Terraform initiates a run, it reads those variables, it sends them to AWS as its credential. But they're static. They're there. They're saved as part of that workspace. Again, they're secure as Terraform can make them, but we've seen issues in the past where third-party vendors do experience data leaks. Anytime something gets written down, anytime something lives in a place, it could leak. So yeah, that's static defense. You can mark them sensitive, obviously, within Terraform, and that's typically what folks do. As you can see, that's kind of what it looks like in the Terraform UI. You've got your access key, you've got your secret key. You mark it as sensitive, and then in theory, no human can ever read that, but it's still stored somewhere. Anything that's stored somewhere, it's immutable, it's written down, it's saved, it's there, it can be read. It might be protected, but it can still be read. So short-lived credentials. What are short-lived credentials? Well, they're generated on demand. Rather than an IAM key that could live indefinitely. We've seen IAM keys over hundreds and hundreds of days, sometimes over 1,000. Never a great thing. Short-lived credentials, though, they're literally just that. They're generated by the STS service, the security token service within Amazon. I think by default they live for about an hour, although that's configurable anywhere from an hour to 12. Short-lived credentials utilize OIDC standard. It permits, in a nutshell, we could spend all afternoon on what is OIDC. In a nutshell, it permits a third party to do ID verification and figure out who you are and what you're allowed to do there. Utilizes JSON web tokens, don't really need to know what they mean necessarily, just part of the OAuth 2.0 specification, which is yet another thing we could probably spend all afternoon talking about if we really wanted to. But again, short session here, so we won't devolve into that too much. Again, specifically within AWS, the security token service, the STS service, it's a global service, which means it's not beholden to regional outages, so availability zones, regions within AWS going down shouldn't be an issue. STS is kind of important. If STS stopped working, bad things could happen. IAM essentially would fall apart, so we want that to be global, and that's a great thing. The credentials are valid in terms of, as I mentioned earlier, credentials are valid for anywhere from an hour to 12 hours, but as far as Terraform's concerned, one and done. Whether that set of keys works within an AWS ecosystem, immaterial to Terraform. Once it's used them, it throws them out. It doesn't actually store them. It doesn't write them down. It doesn't keep them in a database. They're ephemeral. They're gone. And that's every single run. So you do a plan and apply. The plan run generates its own set of keys. It finishes. You do your apply. It generates yet another set of keys. So never two successive runs will use the same authentication to get us there. Terraform service accounts in IAM tend to have really powerful privileges. Most folks just sort of stick admin credentials on them because in essence you want Terraform to be able to do just about anything. So kind of for expedience sake, most folks use admin. Regardless, they're generally really beefy, really powerful. If they walked out the door, that's not great. And again, anything that's static has that opportunity. You could slap it on the back of a monitor on a Post-it note. You could stick it in your password manager. You could stick it in your secrets manager. Employees leave all the time. They walk out the doors for good and bad reasons. Are you rotating those keys every time an employee leaves? Maybe, maybe not. We have lots of workspaces, so rotating those keys independently every time we have employee turnover would be a real challenge. And it has been. Let's see. That administrative overhead, though, just goes away. If you don't have to rotate the keys, that's something less for your IT department to have to worry about. I mentioned earlier, if those secrets ever leaked, those environment variables, again, Terraform protects them pretty well. There's no human way to go read those that we know of, but they're still stored somewhere. Anything that's stored somewhere has a greater than 0% chance of leaking. That's exactly what happened with Circle CI in January this year. They leaked a whole bunch of secrets. If that happened to Terraform Cloud, that could be really devastating. That'd be a really bad day for a whole lot of us. You'd have a whole bunch of really powerful keys out there in the world, and yeah, that could be a bad day. And then last but not least, forensic isolation. Since every single run is marked with a specific set of credentials, if something malicious happened, you always have a single instance, a single run to go back to say, that was where it happened. Ideally, that leads you to who did it, or how it happened, or when it happened. More information, the better, though, from a forensics perspective. So again, okay, so how do we do this? What's our bill of materials? Not much. Really not much at all. When I started researching this and kind of read through, I was like, that's it. Why haven't we been doing this since day one? And hopefully you'll feel similarly when you hear this. So you need a public signing key from Terraform Cloud. They publish a key, a public signing key. Every customer of theirs gets the same key. It just proves that when you receive communication from them, it, number one, came from them and it wasn't tampered with along the way. You need an OpenID provider. That's under the umbrella of IAM on the AWS side. So you create an OpenID provider. It references that signing key, and it also references an audience, which we can show you later. The audience just basically says, who is this meant to talk to? And in this instance, it's IAM itself. We need an IAM role. This is really basic. You create an IAM role, standard, typical, everyday IAM role. Whatever privileges you assign that role, that's what this is allowed to do. Again, that's typically administrator, but not always. I mean, it's probably not a great idea. But for, again, expediency's sake, a lot of folks just use administrator. You need a role assumption policy. The role assumption policy allows the federated ID provider, in this case Terraform Cloud, to operate as that IAM role. And then, in essence, whatever privileges IAM has been granted. And then you need two variables within the workspace. That's it. You need a variable that says true or false. Are we using dynamic credentials? Yes or no. Pretty simple. And you need a second environment variable that is just the ARN value of that role. And that's it. That is all there is to it. It's actually just that easy. I think the first time I implemented this, it took me a little more than an hour, and I was shocked. That was kind of all there was to it. What does that look like in practice? Let's take a quick look at the workflow. So a user would initiate a Terraform run, plan or applied. Terraform is going to talk to IAM and say, hey, I need to get trust information and permission grants. Do I trust that individual? Do I trust that user context? Do I trust where it's coming from? And what is it allowed to do? IAM goes to STS and says, okay, we trust that person. We know they're allowed to do X, Y, and Z. Send the security token back. It sends a brand new security token back to Terraform Cloud, which Terraform Cloud then uses to do whatever you've told it to do. At that point, the key is valid. Again, within the AWS ecosystem, the key is valid. But from Terraform's perspective, doesn't care. It's gone. It will never use that key ever again. Again, if it's a plan and apply, the first run will get a set of keys. It'll do the plan. When you click off the apply, or if it automatically just rolls into apply, it'll get a second set of keys. And that, again, those keys will never be used ever again. Okay, how can we make this better still? Because that's pretty good. Well, this is IAM. So IAM allows us to place conditionals. Conditional language within IAM, I'm not going to get into all that. There's a link in the presentation that can take you to all the global conditionals, but they all still hold sway here. So you can place conditionals like source IP address. You could go get the list of all the public IP addresses that Terraform has. You could make sure that anything coming from them is coming from one of their IP addresses. You can constrain it by the organization name, which is a good idea at minimum. The project, if you use projects within Terraform Cloud, workspace names, you can constrain it to single or individual workspaces or list subsets of workspaces. And finally, you can constrain it to the run phase. We don't, but you might have a set of junior engineers who are only allowed to run plans. You might have a set of senior engineers who are only allowed to run, or are able to run applies and plans. You may have a approvals pipeline, that kind of thing. So you can segment it that way. And again, IAM global condition keys are your friend. You can do all sorts of interesting stuff with them. That is actually it. There's not much more to it than that. I really hope, and oops, sorry, one last picture of the pooch. Let me show you, and this is all in the let's see if I can't do the mirror thing here. Maybe not. Okay. Again, we're not going to step through. That's not it. Sorry. Attached to the artifacts for the presentation, I've got a coded example. It's got the Terraform code in it. It's been fairly sanitized, so keep an eye on it. Look at it. There's a couple of values in there that you'd have to replace your individual environments with, but that's about it. It works really well. Like I said, I was kind of shocked. We'd been using static keys for a very long time. Implementing this was not only easy, but again, it just works, and it vastly improves your security posture, and it really diminishes your attack surface area. And this is something that I really mean this, we come to conferences a lot, and we get big ideas, and we get good ideas, but we have to go home, we have to sell them up the chain, we have to sell them to our colleagues, we have to talk about them. This is something you can go do on Monday. Before the end of the day, you could have this up and running. It's pretty slick. I recommend it highly, and it's working well for us. But again, that's it. It's a short session. I appreciate everyone's attention. I hope you got something good out of this. Are there any questions or anything we could, certainly, we'll get both of you guys, but fellow in white first.
So we use Terraform Cloud, but we're in the process of migrating away from it. Have you found any implementation that applies to something like Spinnaker or any of the CI/CD tools?
I don't know. We don't use those, so it's OIDC compliant. So I would assume any vendor or any service provider that supports OIDC, this should work just fine. You'd have to consult with a vendor to make sure, but I'd be surprised if they didn't. So it's definitely worth looking for. I know Azure, you could do the same thing with Azure. There's an implementation plan for Azure as well. Some of our folks have been tinkering with that, so I have to imagine if it's not there yet, it will be coming. I'm not positive. I'm not an Azure guy myself, so I can't speak to that. But I know it's in the Azure ecosystem. Oh yeah, certainly. If you look at the schedule, if you click on my presentation, there's a coded example and my slide deck are both in here, so feel free to grab them. And you can reach out to me, send me an email if you have any questions. I'd be happy to talk about it. I'm not an expert at this. I didn't invent it. I just kind of pieced it together and implemented it. Yeah.
Just to put it in context, I just went through the same process of cycling through almost 800 keys.
Yep.
Like you said, 300-400 days old.
Yep. Yep. Yep.
We just went with this. We can get rid of that issue.
Yep. Exactly. 100%. And you mitigate the issue of an employee walking out the door with those keys. You can memorize it, you can photograph it, you can take it with you.
It's a mad rush if it's not going to let an engineer go.
Right. Even if someone leaves under good auspices, it's still, it's still due diligence. You had to take care of that just to, yeah. Any other questions or? Okay. So go ahead.
So I understand this flow here. So you're using Terraform Cloud as your identity provider, right?
As our what?
You're using Terraform Cloud as your identity provider to AWS instances, right?
No. Our identity provider, we actually use Okta as our identity provider. So I personally, as an individual, authenticate through Okta. That's how I get into Terraform Cloud. This is how Terraform Cloud then interfaces with AWS. So when Terraform Cloud takes my code and turns it into API calls and starts to build stuff, what user context does it use? How does it obtain those keys? And then in this case, it's getting a fresh set every single time it runs.
So then to extend on that,
Sure.
it's using your identity in AWS, is that correct?
No, it's not. It wouldn't be authenticating. So I could have a general vanilla user. Let's say I have a general vanilla user account within AWS. My IAM credentials give me minimum access to do things. That IAM context is not in play here. When Terraform runs, traditional, old school, static implementation, Terraform has the AWS access key, and the secret key, not of me, of an IAM role we defined that has XYZ privileges, typically admin, right? That is the user context that's in play here. That had been a static set of keys. In this case, it's like a brand new admin or whatever set of privileges you ascribe to it are getting cut every single time. It's like you go into IAM, delete the key, make a new one. You go into IAM, delete the key, make a new, but automatically on the fly. Does that help? Awesome. Certainly, go ahead.
Okay, and this, what you're showing here is specific to Terraform.
Right, yeah, this is specific to, absolutely, yeah. I mean, I guess I have to assume other providers will do something, well, yeah.
Thinking of, like service keys in South, possibly using Vault or another,
Anything, even Vault. So Vault's pretty good. We use Vault for some things, but it's still written down. In my mind, I go back to if it's written down anywhere at all, in any fashion, it can be leaked. It can be exfiltrated accidentally on purpose or otherwise. If it's stored somewhere, it can flutter out the window, Whereas this, that's not even an option. It's a zero. Exactly. Any other questions? Awesome. Well, I really hope you guys found this useful. I hope you take it back and implement it because it's pretty great. I'm a big fan, as you can see. So thank you, though, for your time and attention. Really appreciate it. Have a great rest of your day.